applications of the properties, right? Now we'll see this. So from these basic order properties, we can determine such sets and what are the elements, right? So we want to see one applications which is very essential for us. So if A and B are positive numbers, then prove that so that square root of A is greater equal square root of B if and only if A is greater equal B and only if A square is greater equal B square. So two numbers, one number is greater than another, then their square root also greater than. Same inequality is true. Or if we take powers, then also same inequality holds, provided numbers are positive. Right. So, how will you check this? Suppose first part, if you assume that A greater than B, right? Or before assuming A greater than B, just work out this in different way. So consider A minus B. So A minus B, I can write it as square root of A square root of B square. So whenever I say square root of some number x, then I am taking right, because when I say square root, then it is positive, because if I take x raised to half, then there are two possible values, p plus minus square root of x. But when I say square root of x, that means I am assuming positive value. When I want to take negative, then I will mention it like minus of square root. So whenever I say square root of a, then it is positive square root. Fine. So it is square root of a minus square root of b into square root of a plus square root of b. If you consider this, then since a and b are positive, we have square root of a and square root of b. What can you say about square root of a and square root of b if a and b are positive?
They are real numbers.
Yes, then am I definitely say that these are positive? Square root
Yes,
are
sir,
also
greater than
positive.
0.
Right. Otherwise, if square root is negative, then I will take it square. Then I will get a. That will be positive. So square root means I am taking positive square root. So it is positive. So square root of a and square root of b are positive. Therefore, what can you say about square root of a plus square root of b? Is it positive? Is it positive?
Yes, sir, it's
Yes, sir.
positive.
Definitely it is
Positive.
positive. So now first case, suppose a is greater than b. If a is equal to b, then that is not a difficult case. It is a trivial case. So we are worried only about a greater than b, right? So note that if a is equal to b, then square root of a is equal to square root of b. That is not a difficult case. So we are just uh, assume a greater than b. Then a minus b is positive, right? And therefore a minus b is positive. Therefore, what is a minus b? By previous discussion, square root of a minus square root of b which is square root of a plus into square root of b. So I am assuming a and b positive, so square root of a plus square root of b is already positive, no doubt. And now here I am assuming a greater than b, that means a minus b is positive. That means this left hand side is positive, therefore right hand side is positive, right? So LHS is positive, therefore RHS is positive, right? So this right hand side product of two numbers, two brackets is positive. That means root a minus root b into root a plus root b is positive, right? So under the assumption that a greater than b, I am here the product of these two brackets is positive. But recall the previous discussion or previous properties. If product of two numbers is positive, then what happens? What can you say about the if product is positive?
Both the numbers should be positive or both the numbers should be negative.
Right. So either both are positive or both are negative. But if you know that one of them is positive, then what should be the second?
Positive.
Positive.
Positive. But and in this among these two brackets, we already know that one of them is positive.
Root A plus root B.
Yes, sir.
Right. This implies root a minus root b is positive and root a plus root b is positive, or root a minus root b is negative and root a plus root b is negative, right? So this implies these two possibilities. But second possibility is not there because we already know that root a plus root b is positive, and hence root a minus root b has to be positive, and that means root a greater than root b. So what is the conclusion? What is the conclusion? Thus a greater than b implies root a greater than root b. Fine. Now conversely, suppose root a is greater than root b. That means root a minus root b is positive. And therefore, what can you say about a minus b, which is root a minus root b into root a plus root b? What can you say about the product? Now here our assumption is root a is greater than root b. That means root a minus root b is positive. And already this bracket is positive. And when we say that this is also positive, what is the product? What is product? Positive? Am
Yes.
I right? And what is the conclusion? So root a is greater than root b. And so what we proved, thus root a is greater than root b implies, no, what I am saying here, a is greater than b implies a is greater than b. Fine. So is it clear? Is it clear?
Yes, sir.
If I assume a greater than b, then I can prove that root a is greater than root b. On conversely, if I assume root a is greater than root b, then also I can prove that a is greater. Hence, what is the conclusion? A greater than b if and only if, because both way I can prove this. Equal is not an issue because equal is obviously true, and therefore what is the final conclusion? A is greater if and only if root a is greater equal to b, because equal is not the point of worry, because it is obviously possible, right? And therefore what was our main aim? Our main aim was key this if and only if this. So this part is done now. This if and only if this part is done, right? So we have proved this part. Now can you prove this part? A greater equal b if and only if square is greater equal b square. So next part, suppose a greater equal b or a greater than b, then can I say that a square is greater equal b square? with same logic, whatever we discussed in the first part, same logic you can apply, right? Because why this is so?
A minus B equals to B.
Because a square minus b square, I can write it as a minus b, a plus b, but a and b are positive, so this part is positive. And when I say a greater than b, then a minus b is positive, so positive, 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 and therefore a square is greater than b square. So obviously, or conversely also, conversely, by same logic, a square is greater than b square implies a greater than b. Same logic, whatever we did for square root and a and b, so the same logic works here. So thus, a is greater than or equal to b if and only if a square is greater than or equal to b square. And if we combine first and two parts, so hence root a greater than root b, so root a greater than root b or greater equal, because equality is not to worry because the both sides are same. So greater equal root b if and a is greater equal b if and only if a square is greater equal b square for a be positive, not negative. We are not talking about negative numbers. Fine. So this is clear now how we proved it, and we use very basic idea, right? The product of two numbers is positive, then one of them is both are positive or both are negative. That is the simple trick behind it, right? And otherwise the calculations are trivial. Fine. So using this, arithmetic mean geometric mean inequality. So AM GM inequality. So let A and B are real numbers. Since I want to take geometric mean, so I am assuming positive numbers, because negative numbers will create a problem while taking geometric mean, right? Then what is arithmetic mean of A and B? What is arithmetic mean of A and B?
A plus B by 2.
Right, A plus B by 2. And what is geometric mean of A and B?
Under root AB.
Right,
B square is
Yes.
under root AB. And that's the reason why I take positive, because if I choose negative, then this will create a problem to take geometric mean, right? So square root will not be well defined in that case. Fine. So our question is prove that which is bigger and which is smaller.
AM is greater than GM.
Right. So root
Yes.
AB is less than or equal to A plus B by 2, and equality holds if and only if A is equal to B. If two numbers are equal, then only the equality, otherwise less than, right? In general it is less than, and if A and B are same number, then equal. That is the situation, right? So suppose A and B are positive, then doesn't matter which is bigger,
Excuse
which
me.
is, right?
Sir, I did not get the equality holds part.
Equality means what? When I say square root of AB less equal A plus B by 2, it is less than or equal in general. When equal, when arithmetic geometric mean is equal to arithmetic mean. When it is equal, that is a question, and it is equal if and only if A and B are same. Is it clear now?
Yes, sir.
Right. So suppose A and B are positive numbers, then don't bother which is bigger and which is smaller. Just look at square root of A minus square root of B. I don't know sign of this number, right? I am just looking at the two positive numbers. It may happen that b is positive and b is greater than a, but and therefore sign of root a minus root b may be positive, may be negative, because I don't know which is positive and which is negative. But certainly square, what can you say about the square?
It must be positive.
So greater equal 0. I am not saying ki they are unequal. If numbers are equal, then I may have 0, right? Difference is 0. Is it clear? So see, whatever I am
Yes.
writing, it should be logically correct, and it should include all the possible cases, worst to the worst possible cases. Whenever I say A and B are positive, then that means I don't know whether they are equal or which is greater, which is smaller. But no problem if I take square of this difference, then certainly square is positive. And I am not saying they are A and B are unequal. They might be same. In that case, I should say that the difference might be 0, right? So there is no ambiguity now. It is clear ki whatever the
Yes.
possibility, whatever the cases you assume on A and B, everything is included in this now. Fine. So that is a way to write down the proofs in mathematics. See, as I told you yesterday, it should be like an algorithm. If you make simple error in the algorithm or programming, C programming or Python programming, then it will give error, right? So your program will not run, will not work. Same thing, same mentality should be there while learning mathematics. You should not make any logical mistake, right? So there is no ambiguity. All possible cases are considered here. Fine. Now expand this bracket. Expand this bracket. So if I expand the bracket, what I get? Square root of a square plus square root of b square minus 2 times square root of a into square root of b, which is greater equal 0. Hence, a plus b minus root 2 times root ab is greater equal 0, right? So whenever I say ki this minus this is greater equal 0, what does it mean by order property? So a plus b is greater equal 2 times root ab, right? But if I multiply both sides by half, which is positive number, then still inequality remains same by our previous discussion. So a plus b by 2 greater equal root ab. So what I did here, I multiplied by half, and half is a positive number, so inequality is not going to change, right? Hence, root ab is less than or equal to a plus b by 2. Fine. So our geometric mean is less equal arithmetic mean. Now next part, if a is equal to b, then what is geometric mean? A into a, because a is equal to b, which is square root of a square, right? Square root of a square is what? Square root of a square is a, and I am taking positive square root, so it is a, and a is already positive, so no doubt. And what is geometric mean? A plus b by 2, but a and b are same, so a plus a by 2, so 2a by 2, which is a. And what is the conclusion? Arithmetic mean is equal to geometric
Sir, arithmetic mean
mean.
AM is equal to
Oh,
AB.
arithmetic, right? So if a is equal to b, then arithmetic mean is equal to geometric mean, because I want to prove that if and only if equality is there, if and only if a is equal to b. One way I have proved, if a is equal to b, then arithmetic mean is equal to geometric mean. So am is equal to gm if a is equal to b. Conversely, suppose arithmetic mean is equal to geometric mean, then I want to prove that a is equal to b, right? So arithmetic mean of ab, I am taking numbers a and b, that is understood. So what we are assuming now, uh, a plus b by 2
AM
is equal to right? So that I am assuming, and I want to get that key A is equal to B. That is what my aim is. Fine. So now squaring both sides. Squaring both sides, what I will get, or you can just follow the reverse procedure which we have here. Just follow the reverse procedure, and you will get root A minus root B is equal to 0, and that will give you a root A is equal to root B. But alternatively, there are means. So squaring, what will get, A plus B square by 4 is equal to AB, right? That means A square plus 2AB plus B square is equal to 4AB. That means A square minus 2AB plus B square is equal to 0, because I just subtract 4AB from both sides, and this is A minus B square is equal to 0. And when square of some number is 0, if square of some number is 0, okay, this is the
When
exercise.
both are equal.
Prove that x square is equal to 0 if and only if x is equal to 0. This exercise, you just work out it. And so A minus B square is 0. That means A minus B must be 0, and therefore A is equal to B. Right. So if arithmetic mean is equal to geometric mean, then numbers are equal, or if numbers are equal, then arithmetic mean and geometric means are same. Fine. So is it clear? The second part, equality hold if and only if numbers are equal. That means
Yes, sir.
we'll give the complete proof of this. Right. Fine. Now this is again one more exercise. Let A, B, C.
Sir, how do we prove is 1?
Yes. How do we prove?
0 power 0 is 1.
0 power 0 is 1 is not true. Right. This is indeterminate form.
Okay, sir.
Indeterminate form, so which is not defined. No value is defined to this number 0 comma 0 raised to 0. Right. So that is
Then
not.
we use limit, na?
That is a different story. Right. For that you learn lots
Yeah.
of calculus to apply limits and all these things. But
Okay.
what does it mean? 0 power 0 is not a real number actually. It is a undefined quantity. What is the meaning of this? Whatever real number you select means you choose any. Whenever I say x is a real number, that means it is a clearly defined number. And when I say 0 raised to 0, this number is not in real numbers, means it is undefined, indeterminate. No value is determined from this number, right? Suppose A and B are positive real numbers, then prove that A plus B plus C divided by 3 is, so what is geometric mean of three numbers, right? And what is the
Cube
relation?
root of a number.
What is the relation? Arithmetic mean is greater equal. So for three numbers, can you prove this? You just think over it, and then let A1, A2. So this is a big exercise. You can have, one can work out it and submit it as a big assignment. Be positive real numbers. Be a positive real numbers. Then prove that the geometric mean A2 an raised to 1 by n less than or equal to A1 plus A2 plus an upon n. If you want to prove for any number, you can use induction. So assume for n and then prove for n plus, right? B, n positive numbers. N positive real numbers, then this is true for n numbers also. So you just think about it, right? So this is not very trivial, right? So that means you need to think about it. Anyway, now,
Sir,
yes,
if we prove the last exercise, that is a1, a2, a3 till an, for that we prove that geometric mean is less than or equal to arithmetic mean, then can't it be the proof for the second last one, that is a plus b plus c divided by 3 is greater than equal to a b c?
of course, if you can prove for any n numbers, n number of positive numbers, then ultimately it is true for 3, it is true for 10, it is true for 100, right? So this becomes now trivial if you prove for general, right? But to prove something in general is not easy. To prove for particular 2 numbers, 3 numbers, it might be easy, right? So you just think about it. Okay, now, so let a greater a is a real number, a belongs to R such that 0 less equal a less than epsilon for every epsilon positive, then a has to be 0. So what it suggests, so it's this example or this exercise suggests that if a is a non-negative number, when I say greater equal 0, so if it is a non-negative number and it is less than every positive number, right? So what is a non-negative number which is less than every positive number? Then it must be 0, right? So 0 is the only non-negative number which is less than every positive number. So the problem is clear, right? So proof is a different thing. First of all, you should understand that what the problem says or what question statement says. The non-negative number less than every positive number is the only 0 number, no other number, right? So given that a is a number, non-negative means it is greater equal 0 and less than epsilon for every positive epsilon. What is our claim? Our claim is a must be 0. This is our claim, right? So suppose on the contrary, suppose a is not equal to 0, then when I say a is not equal to 0, then what is a? Do you understand?
A is greater than 0.
Right, because our basic assumption is that a is non-negative, means it is either positive or 0, and when I say it is not 0, then it must be positive, because a has only two possibilities, either 0 or positive, greater than 0. But whenever I say it is not 0, then it must be positive. Then a must be positive. Right. But what is given? Ki a is less than every positive number for every. So if epsilon, or I choose positive number epsilon naught is equal to a by 2. Is it positive? Is it positive?
Yes, sir.
Right.
Yes.
And what is our basic assumption? What is our basic assumption? A is less than every positive number. Then is less than epsilon naught, because this epsilon naught is also positive number. Right? Am I right?
Yes, sir.
Right. So this epsilon naught is also positive number, and our assumption is, our given thing is a is less than every positive number. So a is less than this positive number. That means a is less than a by 2, because because our epsilon naught is a by 2. Is it true now?
No,
Is
sir.
contradiction. Why contradiction? A number cannot be less than its half. Right? A number cannot be less than its half. So otherwise 2a is less than 2. So that is so. Why contradiction? Because a is always greater than a by 2 if a is positive. Right? So in positive, for negative this may not be true, but positive certainly a number is greater than its half. So that is true, and hence, or you can prove it also, so no problem. So we get contradiction because, why we get contradiction? Why we get contradiction? Because we assume that a is not equal to 0. And if a is not equal to 0, the only choice is a is positive. But if a is positive, we get contradiction. Hence, what is the conclusion? Hence, a is not equal to 0 is not possible. Therefore, what is the only possibility? The only possibility is a greater.
It's equal to 0.
Therefore, a has to be 0. That's it. Therefore, if number is non-negative and it is less than every positive number, then it must be 0. So this is a very interesting thing and very useful analysis. Right. And you should remember this. And now I will generalize this. So let a and b are real numbers. Right. A and b are real numbers such that a is less than b plus epsilon for every epsilon positive. Then what can you say about A and B? Do you understand? A and B are real numbers, and A is less than B plus epsilon for every epsilon, whatever positive epsilon you select. See, please understand that for every epsilon means what? A is less than B plus 5, because I choose, you choose any epsilon, A is less than B plus epsilon. A is less than B plus 1 by 2, whatever epsilon, if I select epsilon is equal to half, then also A is less. A is less than B plus 10 raised to minus 2, then my epsilon is 10 raised to minus 2. Is this epsilon positive? 10 raised to minus 2, right?
Yes, sir.
Yes.
A is less than B plus 10 raised to minus 1000, right? Is less than b plus 1 upon 10 raised to 5000. Whatever epsilon, however smaller epsilon you see, every time a is less than b plus epsilon. Whatever smaller epsilon you see, right? Then what is the conclusion? What is the relation between a and b?
A is less than or equals to B.
Right. So a is less than or equal to b. This is the conclusion. That means b cannot be less than a. B has to be greater than a or equal. Is equality necessary? Is equality necessary, or we should say strictly less? Do you understand? Why equality is also there? For example,
Yes.
5. So 5 plus epsilon. If epsilon is positive, then 5 is always less than 5 plus epsilon. Whatever positive epsilon is, 5 is less than 5 plus 10 raised to minus 10, right? So this is
Yes.
true for 5, right? And therefore if numbers are same, a and b, then also this is true, right? So therefore I cannot say ki 5 is strictly less than 5. This is not true. 5 is equal to 5. So if numbers are equal, then also this is true, and therefore less than or equal to b. what is the proof? Can you prove this? What is given? What is given?
A is less than B.
Plus epsilon for every positive epsilon, right? What is claim? A is less than or
A
equal
is
to
less
B,
than B. Yes.
right? We want. Suppose not. Suppose this is not, right? That is, suppose A is not less than or equal to B. Then what is the negation of A is less than or equal to B? What is the negation?
Is greater than equal to B.
Greater than, not equal. Is greater
A is
than
greater than
negation.
B.
Right. So what is
A
the
is
negation?
greater than.
Right. Very good. So A is less than or equal to B. Its negation is A is strictly greater than, not equal, because equality is in this. So negation equality will not there. Right. Then A minus B is positive. A minus B is positive, right? Now if
Yes.
I choose epsilon naught is equal to A minus B divided by, I will take some number 4 for example. You can understand why I took 4 here. You can take bigger number also, but what is the reason that you can understand later on. Then suppose I take epsilon. So certainly this epsilon is positive. This epsilon
Hmm.
is positive, right? Because A minus B is positive, so A minus B upon 4 is positive. Fine.
Yes.
But what is given? A is less than B plus every epsilon, whatever epsilon you select. So given that A is less than B plus epsilon for every epsilon, and therefore A is less than B plus epsilon naught also, because this is also a positive number, right? So no matter what epsilon you select, every time this inequality holds, that means A is less than B plus A minus B by 4, because my epsilon naught is A minus B by 4, right? That means I will just manipulate this. A minus B is less than A minus B by 4, which is positive quantity, because I am assuming A minus B is A is greater than B. So is it true now? A minus B is positive number less than its fourth. Is it true?
No, sir.
Contradiction. Because why contradiction? Because in positive numbers, a number cannot be less than its fourth, but in negative this may be true, right? And I am sure that this number is positive. Why positive? Because I am assuming that A is greater than B. So A minus B is positive and it is less than its fourth, which is not possible, right? Hence A greater than B is not possible, right? And therefore what must be true? A less equal, this must be true. Right. So in the here, what is the purpose of selecting 4 here? That make my job easy to get contradiction. Right. If I select 4 here, that will make my job easy. Even you don't select 4, you just select epsilon net is equal to B minus A. Then what contradiction I will get? A minus B is strictly less than A minus B. That is again a contradiction. If I don't select, if I select 2 here, then also no problem. What contradiction I would get? A minus B less than A minus B by 2. Again, that is a contradiction. So the 4 is not special at all. Remember this. It is up to your logic, what number you select. And I am selecting 4 because I want to be more safer. Very small number is greater than the bigger number. That contradiction I wanted to get. That is the only aim. So it doesn't matter. You can select epsilon is equal to A minus B upon 2020. Doesn't matter. Right, so that is not an issue. The number which I am selecting at the denominator is not an issue. Right, is it clear now? Is it clear?
Yes, sir.
Yes, sir.
Very Fine. So some few more exercises are prove that if 0 less than c less than 1, then 0 less than c raised to n less than c less than 1 for every positive n. Right. So for natural number n, you choose any number n. This is true. So if c greater than 1, then 1 less than c to the power n for n belongs to n. So this you can prove by induction on n, right? And this is not very difficult to prove because when you assume c is and induction works in this case, and you may use strong form of induction, right? So basically, if c is less, for example, let us prove first, and similarly you can prove second. Suppose 0 less than c less than 1. So what is our claim? Right, what is our claim? Our first claim is c raised to n is less than c and c raised to n is positive. Right. So this is our claim. Suppose if c raised to n is not less than c, what will happen? If c raised to n is not less than c, then what will happen?
Then C lies between 0 and 1.
So if c raised to n is not less than c, then it will be greater equal, right?
Oh, okay.
Right. That means c raised to n minus c
Yes.
greater equals 0. But we can factorize this. Right. I can factorize this in this way. So what is this? This is greater equal 0. You can use induction also. Suppose for n minus 1 it is true, then this product is positive, so c must be otherwise. What can you say about this? Anyway, from this, what I can write? From this, what I can write? Because I am assuming opposite. I wanted to prove that c raised to n less than c, but I am assuming opposite. Then I should get some contradiction. So what contradiction I will get?
C is greater than or equals to 1.
C is greater than or equal to 1. Why? What contradiction I will get?
सर कॉन्ट्राडिक्शन ते कॉन्ट्राडिक्शन नाही येते पण c raised to n minus 1 is greater than 0 because तसं फॅक्टराइज केलं आपण so
Oh,
n turns out to be greater than or equal to 1.
yes. Then this implies
Then
c to n minus 1 is greater equal 0 because c is
0.
already right. That means c raised
Yes.
to n minus 1 is greater equal
Greater equal to 1.
right. So to get this contradiction, why c raised to n minus 1 is not greater equal 1?
Oh, okay.
Right. Therefore, first of all, what we need to prove? This will be the second step. This will be the second part. This will be second part. What is the first part of it? I want to prove this. In this, there are two subparts. So what is the first part? If 0 less than c less than 1, then 0 less than c raised to n is less than 1. First of all, prove this. And then I can directly use in this case. Right? Is it clear what I want to say?
Yes, sir.
Okay, suppose not. Right. So see, that is how we are doing this, because where we stuck, then we need to prove that. So let us prove that. So that is how the research attitude, how people do research. If they stuck at some point, they try to prove that. Right. Suppose c raised to n is greater than or equal to 1. What is the problem then? Then c raised to n minus 1 is greater equal 0. Right. But what is this? By if I factorize this, then what is it? C raised to n minus 1 plus c raised to n minus 2. Keep your mic off. Keep your mic off immediately, because you don't forget to keep your mic off. Okay, suppose c 0 less than c less than 1, c is less than 1, then, and I am taking some power of c, then that power is, we want to prove that it is less than 1. Suppose not less than 1, then assume that it is greater equal 1. Then what I get this. Right? Now the product of these two brackets is greater equal 0. What is the conclusion? C minus 1 is positive, and c raised to n minus 1 plus c raised to n minus 2 plus 1 is greater equal 0. Either both are greater, or c minus 1 is less equal 0, and the second bracket is less than or equal to 0. Right? When I say ki the product of two brackets is greater equal 0, either both are greater equal 0 or both are less equal 0. But this possibility is not there. Why? Second possibility is not there. Why?
Because the second bracket will be always positive. It is the addition of positive numbers.
Right. So second bracket is always positive, because, so but c raised to n minus 1 plus c raised to n minus 2 plus 1 is greater equal 0. So therefore second has to be, and c is positive, so all powers are positive, that is clear, and that's why this number cannot be negative. So, and hence one bracket is positive, second has to be positive. C minus 1 is positive, and that means c is greater than or equal to 1, which is concentration. Right? So because what is our basic assumption? This is our basic 0 less than c less than 1. That is our assumption, and then we wanted to prove that c raised to n is less than 1. Suppose not, then what we found is c is greater than 1, which is, and hence what is the conclusion? What is the conclusion of this? C raised to n cannot be greater or equal to 1, so it means c raised to n is less than 1.
Sir, instead of factorization, we can do it some other way.
Yeah, certainly there are other ways.
Sir, because I have one idea, because we can take nth root on both sides. After suppose you wrote that c power n is greater than 1, we can take nth root on both sides, and then it comes out that c is greater than 1 power n.
Yes.
So here itself is a contradiction. So in one line we can prove it more easily.
What is the exercise? If a is less than b, then prove that if a and b are positive, then if and if a to the power t is less than b to the power t, prove this for all t positive. Right? When you are taking nth root, that means you are taking fraction power. And if you take fraction power, then you need to verify it all for all fraction powers. That you can prove certainly. And that means what you are doing, what he is saying, take 1 by n power of both sides. And what does it mean? If c raised to n is greater equal 1, and if I take 1 by nth power on both sides, that means I am selecting t is equal to 1 by n fraction. And if it is true for fraction, then I can say that c is greater equal 1. That will be contradiction, that is right. But before that, you should prove it for fraction powers also. Do you understand what I want to say?
Yes, sir.
Right. Then it is certainly true. If you prove it, then certainly you can easily apply that. But otherwise, the natural way is this. Right. Anyway, no problem. Very good. So there are different ways.
Sir,
Fine.
even in the question you should write that n is greater than 1. I mean n is greater than 0, sir.
N is,
Because if n becomes negative, then c power n will be more than 1.
that is what I am saying, t positive. Right. You take any tth power and positive, t can be 1 by 10. Right.
Yes, sir.
T can be 1 by 100. T can be 1 upon 5,000, or t can be 5,000 itself. So no problem. For all positive t, you can work out this. Okay. So where we were, so what we have proved basically, if 0 less than c less than 1, then any power of c less than 1. That is what we wanted to prove. So, okay, let's go to the previous situation. What we wanted to prove is c raised to n is less than c. Suppose c raised to n is not less than c, then c raised to n is greater equal c, and then c raised to n minus c is greater equal 0. Then we have this factorization. That means both are positive or both are negative, but already c is positive, the bracket has to be positive or greater equal 0. That means c raised to n minus 1 is greater equal 0. So contradiction. Right. So why contradiction? Because if c is less than 1, then its power is also less than 1. That is what we have proved in this case. If c is less than 1, then its power is less than 1. But here what we found, if c is less than 1, then its power is greater than 1. So why we get contradiction? Because we assume that c raised to n is greater equal c. So thus c raised to n is less than c. So this is what we wanted to. But here we use this thing, right? And that's why we proved here. So this could have been proved before this. So this is first and this is second, and then this should be the order. This will be first before this. Fine. So is it clear? Idea is clear. Idea is clear now. The calculation doesn't matter. You can use your own calculation. So this is what I immediately came in mind. So natural way. You can have some different calculation, but certainly you can prove it, right? And similarly, you try to prove second. Fine. Okay. So there are many. So what is the meaning of doing all this business? Whatever properties we have used so far, properties of real numbers, each and everything can be proved now, right? So far you were using all these properties, just you were assuming this is true, that is true, right? So you can prove each and everything. For example, if a is a real number and m and n are integers or whatever you want, you take integers, then a to the power m to the power n is a to the power m into n. So prove this, because you use it at several occasions in school, right? So if a is a real number, then prove that a to the power m into a to the power n is a to the power m plus n. So prove this. So these are the basic facts which you have already used while doing calculation, but how it is true, and that is because of this fundamental axioms, key order properties, field axioms, algebraic properties. The base is this. Right, so that is what the ultimate aim of proving this. We want to understand the structure of real numbers completely. Each and everything, whatever we are using, working with real numbers, whatever steps, whatever properties we are using, each and everything has a reason, and reason goes back to the these order properties and algebraic properties. Right, so therefore these order properties and algebraic properties are building blocks, and whatever properties of real numbers we are using, these are just consequences of algebraic properties and order properties. Consequences, right? And everything can be proved from that only. Okay, so is it clear? Any doubt so far? Is it clear? Everything is clear.